Today's lesson, section 2.6a and b, is talking about combining functions. So the reason why I'm doing a and b at the same time is because we're going to have two assignments that kind of talk about the same thing, just to get you a little extra practice at it. But basically, we're just using the algebra, so addition, subtraction, multiplication, division, and we're talking about composition with the domain part of it included. Okay, so here when I add two functions inside, like of the same x is the same thing as just adding them, same thing as subtracting, divide, or multiplying, dividing. So that's kind of what they look like. It's just notation. So when you see these, let's use a different color. When you see these notations in problems, just know that they mean those things to the right. So f of x plus g of x is the same thing as those, so just so you're not confused. Okay. Now for your problems, you're going to be asked to take two functions that are pretty much different, and you're asked to add, subtract, multiply, and divide. And then for each of those functions that you've newly created by adding, subtracting, multiplying, dividing them, you need to state their domains. Okay? So here, if I have f of x is 1 over x plus 1 and g of x is the square root of x, to add, now don't make this any more complicated than it already is, okay? Because it's really not. So if I take f plus g, now notice I have two functions that are really not similar at all, right? Because you have 1 over x plus 1 plus the square root of x, okay? Now, do you really have any like terms there? No. There's not a requirement to make common denominators or anything when you're doing these, so don't think that you have to make common denominators unless they specifically say to or say simplify. Here they're not like terms, so that's not a big deal. So this is basically your function for addition. Okay, it's pretty simple. Your domain, now you have to go back to a previous section where we talked about finding your domains. Okay, here you have a problem where you have something in the denominator and you have something underneath the radical, okay, together. Okay, so look at your domains for both of them. So like for 1 over x plus 1, your domain is just everything but negative 1, right? Because it can't be negative 1. So you can go from negative infinity to negative 1, and then union negative 1 to infinity. For this one over here, you can't be less than 0, right? But you can be 0 or anything above, so your thing would be from 0 to infinity, right, for your domain. So now you need to take those two domains and combine them into one that reflects all the domains that they, like all the values that they have in common. Okay? So because of your radical for your answer, you can't have it be less than negative 1. Okay? So it just doesn't work like that. Here, negative 1 still doesn't work for the radical, but it can be 0 for this function and this one. So together, the overlying would be the radical. And now it's not always the case. Sometimes, depending on what this denominator is, it could change or alter what you're doing, because there maybe is another number you can't include or something like that. But for this case, your number is going to be just less than or equal to 0 all the way to infinity. Okay? Or sorry, including 0, comma, infinity. So let's move on to the next one. Now, subtraction is very similar to addition. So you have 1 over x plus 1 minus the square root of x. Okay. Notice that we're dealing with the same functions. The only thing different about this function is that instead of a plus sign in between them, there's a minus sign. Okay, so your domain really didn't change at all, right? You didn't change anything about the underneath the radical. You didn't change anything about the denominator. So then your domain is actually exactly the same. Okay? If I multiply the two, okay, that means I take 1 over x plus 1 times square root of x. Now here you could simplify it a little bit by saying square root of x over x plus 1. Okay, so then that would be your answer. Let's box those, right, to make sure we know where our answers are. Now here, mathematically, just because you put the radical on top of the fraction in the numerator really didn't change anything, right? You still have this radical, you still have the denominator, so your domain is actually still the same. Okay? Now usually, let me specify, usually it's not always the case, but usually your addition, subtraction, and multiplication will have the same domain, okay? Which is kind of nice, so you don't have to think really super hard about it, but there are some cases that you may come across where the domain is different for some of the other ones, depending on what goes on with your addition, subtraction, multiplication. Okay, so just know that that's going to happen. That may happen, but usually your domains will be the same. It's the one that's the division that makes everything for your domain different. Okay, now it may not drastically change your domain, but it could have a serious effect. So like here I have 1 over x plus 1 over square root of x. Now here you can't have a complex fraction, so you need to keep it, change it, flip it, or multiply by the reciprocal. Okay, so your top one stays exactly oriented the same. Then you flip the bottom, changing the operation from division to multiplication. Okay, so I can simplify this one by saying square root of x times x plus 1 underneath my radical, or underneath my denominator. Okay, and so then I have that. Okay, now nothing drastic changed. It's just that now you have a radical in the denominator instead of the numerator, so it can't be 0, right? So we can't use our bracket anymore in comparison to our 0 in our interval notation. So I need to have a parenthesis instead of a bracket. Okay, but that was the only real difference there. Sometimes it's more drastic, sometimes it's not. Sometimes it could actually still be the same, but division is usually the one that's gonna change the domain for sure, because of you're putting something new in the denominator that wasn't there before. Okay? Now the next thing that we need to talk about is composition. So composition of a function is when you have two functions, f and g, that are a part of a composition where you write f composition g. It's that little circle there that means composition, okay? Which is defined as, when I write this, it means that I plug in a function into another function. Okay? That's basically what composition is. So here you're given two new functions. F of x is x squared, g of x is x plus 2, and now I want you to do the composition of both, so both ways. So f composition g and g composition f, and then find their domains. Then also working on plugging in a value in for that function when you do it. Okay? So let's try this. So composition, think of composition as just substitution. So like if I took f of 2 in for my function of f of x, notice that I put in a 2 where the x is, right? Because that's what I'm stating over here from my function notation. And that's how we get 4. So now if I want to do f composition g, then that means that I'm going to plug in g, just like I plugged in 2. Okay? So whatever my function is for g of x, so it's like saying f of x plus 2, is going to be inserted in for the x value, wherever that x value may be. So like here, I have x squared, right? So my x would be right there, and it'd be squared. So now I'm going to plug in x plus 2 in for x. Okay, so it's like a new value. And so now they want you to simplify, so x plus 2 squared gives you x squared plus 4x plus 4. Now here, your domain is going to be a little different because you still have to take in account of what your previous domain was. Okay, so let's look at our domains of what the basic functions were. Now looking at x squared and x plus 2, there are no restrictions for your domain, so both are all reals. Okay. So then, since that's the case, if I plug in something all reals into another all reals, it's not really going to change very much here. So since this is all reals and that's all reals now, then it's still going to be all reals. Okay? Now if there's something you're plugging in that has a restriction, that restriction still applies, even though this might have come out as something that has no restrictions. Okay? Because you're always going to be plugging into this one first before you plug into the last one. Okay, so the composition. So let's do the other way. So if I have g of f of x, okay, so that now I'm plugging in f's function into g's function. So that means I'm taking x squared instead of x plus 2 and plugging into x plus 2. So then where I would have an x would be right here. So I put an x squared. Okay? Now there's nothing else to simplify there. So I just have x squared plus 2. And since x squared was all reals, x squared plus 2 is all reals too. So then I still have the same domains. Okay, now I'd like to try plugging in a value. So since we already found f composition g, I want to do it of 2. So f composition of g, so another way of writing that is, so since you already found that it's x squared plus 4x plus 4, then that means I can do 2 squared plus 4 times 2 plus 4, which gives me 4 plus 8 plus 4, which is 16. Okay, and then g of f of negative 3, right? So then now, since I have x squared plus 2 there, negative 3 squared plus 2 gives me 9 plus 2, which is 11. So those are those two values that I needed to find. Okay? So that's the basics of composition. Okay? Have fun.